Let's get one more. Man, it's still kind of slick out there, isn't it?
Yep.
Yeah, it's so gross. Somebody got hit by water.
It's pretty bad. I mean, gosh, this morning I almost ran into some up dog on the way back into my car. It's terrible. I did. I almost ran into some up dog on the way in.
I like Snoop Dogg.
No,
Up dog?
no, is it Snoop Dogg?
I know what you're
Just
doing.
ran into some up dogs.
I know what you're doing.
Oh, you're doing
I almost ran into some up
What's
dogs.
up, dog?
I didn't answer.
He didn't say not much. He just smiled and walked away. I did almost hit a dog.
Did you? Okay. All right, here we go. Here we go. Okay, so real quick, bring us up to speed. It's been a few days, so I want to just do one quick example. I have put up some due dates on Moodle, and due dates, we're going to kind of be a little more precise about due dates on this semester. So a few changes. I am going to close down assignments, so you are going to have to get them done within a couple week time frame. The other thing is, we're going to take our after test. We're going to do our test in class, and then in order to even qualify, the retakes won't even open up for you until you have gotten 70% or higher on the review assignment. So you have to, which for most people isn't going to be a big deal.
Is it the same review that you do before the
Yep.
test?
Yeah, so as long as you get, yeah, but you have to do it in other words to take the test. Okay. All right. So here we go. Now, prior to the end of the semester, we had started to look at, we'd looked at a bunch of quadratic stuff, factoring, which we practiced, but I promise I'm about to give you a great little trick for avoiding having to do any difficult factoring. I made you do it because it's an important skill, but we're really only going to use it as a technique for solving equations when it's convenient. We're not quite to that point yet, but we had another kind of problem like this, where we were able to solve these pretty easily without doing factoring also. What was our approach to solving an equation like this? Okay, backwards PEMDAS. Yeah, we're going to isolate x. And what about this problem? Okay, what about this problem makes it one where we can do that, where we can isolate x? It's only one x. Good. Okay, so we have a single x. There it is. When there's a single x in an equation, we can isolate it on that one side of the equation, right? And so you got to get yourself in the right way of thinking, though, when you're doing this. Remember that our goal here, when we're isolating a variable, we don't have to do anything real tricky. We don't have to do any expanding out or foiling out or anything like that. We're just going to try to pick everything away from the left side and move it to the right side except the x, to leave the x by itself. And our roadmap for doing that is, what do you guys call it, SADMAP? PEMDAS backwards?
That's awesome.
Okay, is reverse PEMDAS, yeah. Okay, so that tells us what steps to do in what order. So first of all, can we add or subtract anything to both sides here? No, we can't. Nothing outside of parentheses needs to be added or subtracted. So we skip the first rung, up to the next rung on the ladder here. Multiply or divide. Okay, yeah, now what are we going to do here? This is a little strange. Okay, that's one way of thinking about it. I've got this negative 1/8, and maybe it helps to even put this in parentheses, right? That's being multiplied by the factor that has the x in it. So we want to undo that by dividing. So we divide both sides by negative 1/8, except we really never divide by fractions. What do we always do instead?
Multiply by the reciprocal.
Good, we multiply by the reciprocal. So I want to just practice a couple of these. So what if we had, for example, I want you to tell me, if I want to get the x by itself and I have a 2/3 x, what do I do? Okay, I'm going to multiply both sides by 3/2, right? So the reciprocal of 2/3, if that equals 11 or something, I'd multiply both sides by 3/2 to get rid of the fraction from the left side. What if I had negative 2/5 x equals 7? Okay, almost. Negative, good. And the reason we want to multiply by a negative, and the reason we want to do that is so the negative and the negative cancel, and I just get a 1 left over. That's my goal, is to completely get rid of that fraction, right? Does everybody see that? So I've multiplied both sides in this case by -5/2, and then those completely cancel, and I just end up with an x on the left side. Okay, so when you multiply by a reciprocal, it does include the sign also. So going back to our problem then, now what am I going to multiply both sides by? Good, -8, right? Or -8/1, however you want to think of it. On this side, we'll just make it a -8, right? Because it's just multiplied by an integer. Over here, it did its job. It canceled the fraction, leaving me with just the quantity x plus 3 squared. On this side, I get what? Negative, whoops. -56. Okay, so we finished that step. Now climb the ladder one more. What's next? Okay, exponents. Does that mean I'm going to FOIL this out? No, I don't want to do that. My goal is I want to get this 2 away from there. I'm not trying to do anything to it other than get rid of it, right? So how do I undo a squared then? Square root. Okay, so if I square root both sides, that's great over here. It does what we want it to do. It gets rid of the squared, but what's different about the right side than what we dealt with first semester? Yeah, there's a negative number under the radical. So there's where this gets a little bit strange, right? So there's 2 parts of this we got to be aware of then. So I've got I square rooted both sides, which gave me on the left side just a plain old x plus 3. Now whether I get a negative number or not inside the square root, if I square root both sides of an equation, what do I always have to include? Plus or minus. Good. Okay, so I got to get that plus or minus there. Now we got the issue of the square root of -56. Okay, so let's take a look at that. How do we deal with the square root of -56? Jake, what do you think? Ideas about that? How am I going to deal with the square root of a negative number?
You have to do the, find the perfect square root of it.
Okay, so now, I don't, for now, I don't even care if we simplify the radical part. What I'm interested in is how do we deal with that negative sign in the radical? Say it again? It's going to be an I, isn't it? Yeah, we're going to be able to split this up. And so really all we're doing with this, if I take the square root, if I have the square root of -56, I'm just breaking that up into the square root of +56 times the square root of -1, right? What is the square root of -1?
1.
No. What do we call that?
I.
That's I. That's the definition of I. Right? So that just becomes an I. And so the moral of the story is, whenever we start with the square root of a negative number, we can just rewrite that as the square root of the positive number times an I outside of the radical. Okay? Make sense? Okay? And so if we go back to our problem then, we end up with x plus 3 equals plus or minus square root of 56i. What's the last step to get the x by itself? Perfect. We're going to subtract 3, which is the same thing as adding -3, and we want to put it in front of the plus or minus sign. So we end up then with our 2 answers being x equals -3 plus or minus the square root of 56 times I outside of the radical, right? Okay, now in the assignments, the Moodle assignments you're going to do about this stuff, from here on out, the rest of the chapter, there are going to be 2 kinds of instructions on the problems, and one of them you're going to probably like a little more than the other. One of them is going to say something like, provide exact solutions. Exact solutions, that did not say exact simplified solutions, did it? It just said exact solutions. And I think it'll also say something like, reduce all fractions. So in other words, it does want you to do things like if you had 2/6, 2/6, you'd reduce it to 1/3, right? But it doesn't demand that you simplify the radicals. You can leave the radicals as a square root of 56, which really is fine. It's an exact answer. The square root of 56 is exact. If I turn it into a decimal in my calculator, all of a sudden it's an approximation. All that means is that we're using square roots instead of decimals. And so if I wrote down the two answers in this form, they would just be -3 plus the square root of 56i, comma, -3 minus the square root of 56i, right? Now, what if, though, the other form that the instructions might take is they might ask for exact simplified solutions. So if we want that, then we actually do have to reduce those radicals, those square roots, simplify the square roots, right? How do we do that? If I want to simplify the square root of 56, let's go back to this page for a second. If I want to simplify the square root of 56, I want to find the biggest perfect square factor of 56. So let's make a list of the perfect squares. 2 squared is 4. What's next? 9.
16, 25, 36, 49, 64.
Okay, and that's probably as far as we need to go, isn't it? So what's our strategy for finding perfect square factors? Is 56 a perfect square? No, it's not. 56 is not itself a perfect square. So the next candidate that we'd even consider would be half of 56, right? Half of 56 is 28. And so really the only ones I have to consider are those that are less than or equal to half of 56, right? Does 25 divide into 56? No. Does 16? No, it doesn't. Does 9? No. Does 4? Ah, it does, yeah. I can write 56, can split it apart into 4 times what? 14, right? So I can break it into the product of those two separate square roots, and then square root of 4 is? Okay, how do I know that I'm done? I can't, you're right, there's no perfect square that divides into 14, is there? So I'm done. Okay, so then on this previous page, if I wanted to write this in exact simplified form, it would just look like -3 plus 4 times the square root of 14i, -3 minus, not 4, what should it be? 2, not 4, square root of 4, right? And -3 minus 2 times the square root of 14i. If I did expect them to be simplified. Okay, make sense? Okay? 205.